Hi, I'm Phil Norval, and this short video is about air-to-air heat pumps for small businesses. I'm going to give you an introduction to air-to-air heat pumps and how they could help your business reduce energy costs and cut carbon emissions. A lot of people are more familiar with air-to-air heat pumps than they realise. What we're really talking about is a modern air conditioning system, but instead of them working to cool a building down, they run in reverse to heat it up. To see what we mean by this, it's worth explaining briefly how a heat pump works. Heat pumps are about moving heat from one place to another using a fluid called a refrigerant. The refrigerant has a boiling point that's lower than the outdoor air temperature, so as it passes through the outdoor heat exchanger, it evaporates and takes some of the heat from the air along with it. This gaseous refrigerant then passes through a compressor which rapidly increases its pressure, which in turn raises its temperature. The refrigerant then flows into the indoor heat exchanger or condenser, where it cools down and condenses back into a liquid. As it condenses, it releases its heat into the room. The refrigerant then returns to the outdoors via an expansion valve, which drops its pressure and temperature, ready for it to be evaporated again. The refrigerant continues round and round this circuit, gradually warming up the building and keeping people warm. So now we know how they work. What's the advantage of these heat pumps? Why wouldn't we just want to use an electric heater instead, if they both run on electricity anyway? Well, as we just saw, the refrigerant is used to take heat from the outdoor air and bring it indoors, so the system is mainly just moving heat from one place to another. The heat isn't entirely free though, because as we saw, there is a compressor and a fan at each heat exchanger, which all require electricity. On average, for every 1 kilowatt hour of electricity used, around 3.5 to 4 kilowatt hours are emitted indoors. This ratio is called the coefficient of performance, or COP, and it's usually provided by heat pump manufacturers to indicate the efficiency of their products. So the benefit of an air-to-air heat pump is quite clear, but there are some important things to consider to make sure it's a feasible option for your building. These can include the location of equipment, system design, aesthetics, and how the space is used. To give an idea of some of these factors, here's a brief overview of the key system components and setup options. The minimum system components are an outdoor unit, an indoor unit, refrigerant pipes, an electrical supply, and a controller. The outdoor unit should be carefully located to ensure it has a good free flow of air around it and that there is no interference from other heat pumps. They also give off some low-level noise, which is something to consider if there are any neighbours nearby. The indoor units have a number of different styles, but they all ultimately have a heat exchanger and a fan to blow the warm air into the room. One practical advantage of air-to-air heat pumps over radiator heating systems is that the indoor units are most often ceiling mounted, which frees up the wall space at ground level. This is particularly useful in shops where wall space is usually at a premium. Most air-to-air heat pumps have the option of a portable or wall-mounted remote control, which senses the room temperature, as well as allowing the occupant to select the desired room temperature, whether it's on or off or on a timer. Individual indoor units can have their own dedicated controller, or multiple units can be grouped together into zones. This is particularly useful for heating large open plan spaces, or simply for ensuring that the whole building or a whole floor is being heated in the same way. This gives air-to-air heat pump systems the potential for a very high level of control, with separate times and temperature settings possible for each indoor unit. With this high level of control, however, it's important to think about the risk of one indoor unit operating at a different set point temperature to that of a unit next to it, particularly if they can also be used in cooling mode. This could result in the two units working against each other, resulting in neither system reaching the desired temperature and wasting a great deal of energy for little benefit. So that's the basic system, but there are a few different setups which can be chosen depending on what's most suitable for the site. Firstly, the simplest system, which we've just seen, is a single outdoor unit and a single indoor unit. This is known as a split system. Costs and outdoor space requirements can be reduced for slightly larger installations by using multi-split systems, where a single outdoor unit feeds multiple indoor units. Or for larger buildings, it's more common to see heat pumps that operate from a centralised plant that combines the evaporator, condenser, and a ventilation air supply fan. Heat from these package systems is distributed around the building through a system of air ducts. Air-to-air heat pumps are usually best suited to sites with large, open-plan spaces, and the number of indoor units for a given floor area can be kept to a minimum. Although there is a high level of controllability from individual indoor units in each room, the costs can quickly mount up. The cost of an indoor heat pump unit is considerably higher than that for a typical radiator. So, for instance, in buildings with a large number of small rooms, it might be worth considering an air-to-water heat pump instead, as their heat is emitted from radiators and therefore might be more cost-effective. If the site also needs comfort cooling, which can't be managed by a simple fresh air ventilation system, an air-to-air heat pump might be a good solution, as they can generally provide cooling as well as heating from the same system. There's no fixed cost for air-to-air heat pump installations because the costs vary depending on a number of factors. Things like what size is the space that needs heating, how many separate rooms need heating, what is the access like for installing the outdoor unit, how far apart will the indoor and outdoor units be, and therefore how much refrigeration pipework is needed. The savings generated from installing one depend not only on the COP of the heat pump, but also on the fuel type and efficiency of the system that it's replacing. Although the number of kilowatt hours used by an air-to-air heat pump will nearly always be much lower than almost any other heating system, electricity is still relatively costly compared with things like gas. This means that a heat pump is only likely to achieve fairly modest savings over a modern gas boiler system, for example. To be sure of a reasonable cost saving, gas prices would need to be no more than about a third of the cost of the electricity for any given site. Where a heat pump is replacing conventional electric heaters, however, the system can be expected to use only a quarter to a third of the energy due to the COP explained earlier. Air-to-air heat pumps are generally very reliable, but as with other air conditioning systems, they do require some maintenance. As a minimum, an annual service should be carried out by a qualified heat pump engineer. They will ensure that things like the heat exchangers are clean and free of debris or weeds, and that the pipe lagging is all intact and in good condition. Also, they'll check that there are no refrigerant leaks and that the correct volume of refrigerant is still present in the system. Not only do refrigerant leaks mean that a heat pump will not operate efficiently, but some refrigerants are highly potent greenhouse gases, and so they need to be prevented from being emitted into the environment as much as possible. Each type of refrigerant is given a global warming potential value, or GWP, which is their effect on the Earth's climate over a 100-year period when compared to carbon dioxide. So CO2 itself, therefore, has a GWP of 1, whereas some of the older refrigerants, such as R410A, have a GWP of 2000. That means that 1 kilogram of R410A has the same impact on the climate as 2,000 kilograms of CO2. Some of the most damaging refrigerants are being steadily phased out in favour of some with far lower GWP values. R32 refrigerant has become a popular alternative, but this still has a GWP of 700. Some systems are compatible with things like ammonia or CO2 itself, and they're becoming much more popular in large commercial heat pumps. So I hope you found this video useful. You can find more information out about air-to-air heat pumps by downloading our fact sheet. Or if you're interested in any other technologies, we have a selection of other videos also available. Thanks very much for watching.